Hello and welcome. Today we're looking at the reactions of aromatic compounds presented to you by Science Visualized. The most important reaction is the electrophilic aromatic substitution reaction. In this reaction, one of the hydrogens on the benzene ring is substituted by an electrophile. So you end up with an electrophile occupying the same position that the hydrogen was occupying. There are various reactions that follow this sequence. The first one is bromination reaction, where bromine Br2 with metal catalyst FeBr3, ion 3 bromide, is used to generate a Br plus electrophile. Remember, you need an electrophile. And then that electrophile will replace the hydrogen. So in this case, the bromine will replace that hydrogen, and here you end up with Br instead of the electrophile, instead of E. The next reaction is chlorination, where you use Cl2 and FeCl3, and that gives Cl plus electrophile, which then will replace the E with a Cl. Next is iodination, which uses I2 and CuCl2. Nitration uses nitric acid and sulfuric acid, and that gives NO3 electrophile, which will then replace the E with NO3. Next is sulfonation reaction, where you use SO3 and sulfuric acid. Then after that, Friedel-Crafts alkylation reaction, where you use alkyl halide. X there is a halide, where X can be chlorine, bromine, fluorine, or iodine. And you use that with a metal catalyst, aluminum trichloride, and that will give you a carbocation as the electrophile, which will then replace the E, as we've seen. The last one is Friedel-Crafts acylation reaction, where you use an acyl halide. So you have a halogen at the acyl position, and that is used with AlCl3 to give you the acylium ion, which will then replace the E. Thank you. Please subscribe.